We're going to look at heat engines and combustion today. And so this is what a turbine looks like. It's just a multi-bladed fan that can either compress air or be pushed by expanding air. This is what a regular coal facility might look like, where you have coal coming in. The stacks, this is a stack from the exhaust of the coal, which can have awful things in it. This here is only steam. And again, why do we have steam? We have steam because we need to get rid of the waste heat to cool the low pressure side of the turbine. So let's take a look at the plants. We could have a simple cycle plant, which is usually a Rankine cycle, a steam turbine. They're very cheap, but they're inefficient. And so you get more fuel costs and more carbon emissions. A Brayton cycle is somewhat better. It requires gaseous fuel, which is more expensive, but it's a more efficient machine, gives you less carbon, but it's more expensive to build. The combined cycle is the most efficient. That's the Brayton cycle plus the Rankine cycle. Say natural gas combined cycle, an NGCC. These are much more expensive, but they're more efficient, and so by definition they're cleaner because you get more energy out for the same amount of pollution that's produced. It's worth noting that with coal you're really limited to a Rankine cycle because you can't gasify coal. And you say, well, yes, there are coal gasification plants, but they're very difficult and there's only a few experimentally worldwide. So we understand when we talk about coal, it's almost always Rankine cycle. Brayton cycle is natural gas, and so of course with the combined cycle it would be natural gas. So what's the connection to the environment? Well, you're going to get some pollution when you're mining or drilling, and we can talk in the future about some of the new techniques for mining gasoline, petroleum, and natural gas that are very damaging to the environment. And you have waste heat because in order to get rid of that heat, you're going to put a lot of heat into the ocean or a body of water or boil a lot of steam into the air, and that's going to have environmental effects. There's also the pollutants in the exhaust. And then there's the issue of environmental justice. So it turns out that the World Health Organization estimates that there's 600,000 deaths a year in China due to the exhaust from coal plants. In the United States, the estimates I've seen are between 20,000 and 50,000. And so this is because of the pollution due to the coal power plants. And so you ask yourself, who lives next to coal power plants? I wouldn't live there, and I won't live there because I can afford to live elsewhere. And so the people who suffer are the poor people who can't afford to live elsewhere. And there's often racial issues involved because there's a connection in the United States between race and wealth. And so you ask yourself, if we had, for instance, especially in China, if we had lax laws on emissions, who suffers? Well, it's the poor people who live next to the facility. Who benefits? Well, it's the rich people who own the facilities and manufacture with the cheap energy. And then the last one is, who makes the laws? Who makes these lax environmental laws? And it's going to be the rich people who run the government. And so there are a lot of ethical issues involved with this pollution and control. So let's take a look at combustion a little closer. We have fuel plus oxygen gives us heat and carbon dioxide. So what does that look like? Well, how about if your fuel is just carbon, that black gritty stuff like in the lead of a pencil or briquettes? You add oxygen to it, you get carbon dioxide. That's it. Natural gas. The biggest constituent of natural gas is methane, CH4. Now when you add oxygen, you get carbon dioxide, plus the hydrogens of the methane wind up with a lot of water. And petroleum. You have long chains of carbons and hydrogens, and then you have to add a certain amount of oxygen. You're going to get carbon dioxide and again water vapor. When it cools, it will turn to liquid water. That's why when you first start your car while the exhaust system is cool, you'll see liquid water dripping out the tailpipe. Now, coal is an interesting thing. It's very complex and it has a whole bunch of stuff, including impurities like mercury and sulfur in it. And so when we burn it with oxygen, we get a lot of carbon dioxide, we get a lot of water, and we get all kinds of pollutants due to the impurities in the coal that we put into the atmosphere. And the amount of impurities is going to be proportional to the amount of impurities that were initially in the coal when we burn it. So you have cleaner coal and you have well, you don't have clean coal. Let's say you have dirty coal and you have really dirty coal. So we want energy, we want heat, but we don't want the carbon dioxide emissions. So the ratio of carbon dioxide, or kilograms of carbon dioxide per megajoule, is the carbon intensity of our energy. Let's take a look at this more closely. I'd like you to memorize these. The carbon intensity of some fuels in grams of carbon per megajoule that you get out for energy is natural gas is 15 grams of carbon per megajoule produced, petroleum is 20, coal is 25, and wood is 30. And so if you're burning something, you realize natural gas is not so good. You get 15 grams of carbon. But petroleum is way worse. You get 20 grams of carbon. Coal is worse still, and wood is the worst. So let's take a look. What if we wanted to know about carbon dioxide? Well, we know the masses of these different elements, and we can add up the mass of carbon dioxide and get 44 grams as opposed to the 12 grams of carbon. That ratio is 3 2/3. So if this is the emission of carbon per megajoule, by multiplying by 3 2/3, we can get the emissions in grams of carbon dioxide per megajoule. So 51, 73, 92, and 110. And so you ask yourself, well, when I say carbon intensity, what do you use? Do you use grams of carbon or do you use grams of CO2? You have to specify, because people use those terms interchangeably. So if someone says our carbon intensity is 60 grams per megajoule, you have to ask, is that 60 grams of carbon or 60 grams of carbon dioxide?